The lesson topic for this video is permutations and combinations with and or. Okay, so we're going to just start with an example that shows the difference between an example with the word or and an example with the word and. So the situation is you have 8 different pencils and 5 different pens on your desk. The first question is, how many ways can you choose 2 pencils or 2 pens? So let's say you're going to grab some things and head off to school. So how many ways can you choose 2 pencils or 3 pens if that's what you wanted to bring to school? The second example or question asks, how many ways can you choose 2 pencils and 3 pens to bring with you? Now think about the difference. Okay? In the first example, you're going to end up walking away from your desk, go to school with 2 pencils or with 3 pens. So either 2 total items or 3 total items. In the second example, you're going to end up walking away with 5 items. In how many ways can you choose 2 pencils and 3 pens to take with you? Okay, so how do we compute these? Well, the first example with or, it's how many ways can you choose 2 pencils or 3 pens? Well, that means we need to find out how many ways we can choose 2 pencils to grab and bring to school. And then we need to find out how many ways there are to choose 3 pens. And then, since you're going to do one of them or the other, we'll need to add their totals. Because then that will be how many different options there would be for what you could bring. So if you have 8 pencils, okay, total, let's decide here if this is a P or a C situation. Is this a permutation? Does order matter? If you're grabbing 2 pencils and bringing them with you, is order involved or important in grabbing those 2 pencils? No, it is not. So this is a combination. And we have 8 pencils, and we need to grab 2 of them, so 8C2. And we'll compute that in just a second. The other option is that you might grab 3 pens instead. So again, we have 5 total pens. Again, it doesn't matter about order. Order's not involved in grabbing 3 pens. And you're going to grab 3 of them. So we need 8C2 and we need 5C3. And then we will add our 2 answers and we will get our total. So 8C2, if you compute that on your calculator, is 28. And 5C3, if you compute that, is 10. And 28 plus 10 is 38. So there are 38 different ways that you could grab either 2 pencils or 3 pens. Because there's this many options in the first situation, there's this many options in the second situation, and one of those 2 things is going to happen, so 38 possible ways. Again, the second one's different. How many ways can you choose 2 pencils and 3 pens? So what this actually is 2 different events. You need to grab pencils, and you also need to grab pens. Because of that, we use multiplication to separate the 2 events. We're going to have a certain number of ways that this can happen, and then each of those ways that this can happen can also be matched up with one of the possible ways that the second thing can happen. So when you've got 2 different events going on, you will multiply the different outcomes, number of outcomes. So choosing 2 pencils, again, order is not important here. We still have 8 pencils. We're going to choose 2 of them. And then we have 5 pens, and we are going to choose 3 of those. And we are going to need to multiply, since they're 2 separate situations that we are going to do together. Okay, so again, we have 28, and we have 10, and we need to multiply them. 28 times 10 is 280. There are 280 different ways that we could grab 2 pencils and 3 pens and walk out the door. Let's try another example. An art gallery will either arrange 6 pencil drawings or 3 clay sculptures at the art show. In how many ways can they create the display? Okay, so let's look for some keywords here. First of all, arrange. They're going to arrange them. If you think about, is it P or C? This will be a permutation. An arrangement of things means that order is involved. So arranging means that we are going to use P, permutation, and then look for the other keyword. The other keyword here is or. The art gallery is going to arrange 6 pencil drawings or 3 clay sculptures. So when we have or, remember, we are going to add the different possibilities for the 2 items. So what are all the possibilities for grabbing this, or arranging, excuse me, the 6 pencil drawings? What are the number of ways that you can arrange 3 clay sculptures? And then that will give us, when we add them up, all the possibilities. So it's a permutation, and we are going to start with our pencil drawings. So there are 6 pencil drawings, and we are going to arrange, as it doesn't really specifically say, but it says you're arranging 6 pencil drawings. So you're arranging all 6. So that's 6P6. And then arranging 3 clay sculptures, again, P for arranging them. 3 sculptures, we're going to arrange all 3 of them. And we're going to need to add the possibilities, whether they decide on the pencil drawings or the clay sculptures. So 6P6 calculated is 720, and 3P3 calculated is 6. There are 726 different ways that you can arrange the art for the art show. This set of examples uses the same original situation. There are 8 boys and 11 girls at an after-school club. Now each of these situations is a little different. The first one says, in how many ways can 3 of the boys be chosen for a game? So if the situation is you're choosing 3 boys, the girls are not involved in this question at all. We don't need to add up the 8 boys and the 11 girls and get 19. We're just saying how many ways could 3 of the boys be chosen? So there's 8 boys, and we're going to choose 3 of them to play a game. Well, that's a combination because it doesn't matter what order they are chosen in. They all 3 will be playing the game. We're going to choose 3 of them. So 8C3 ends up being 56. The second question, in how many ways can 3 of the girls be picked for a game? So same situation, but this time it's the 3 girls out of the 11 girls. So 3 girls. So there are 11 girls. We're going to choose 3 of them to be involved in the game. Order is not important here. And that is 165. Now the next question asks, in how many ways can 3 boys and 3 girls be chosen for a game? Sorry, this should be a question mark here. All right, so this time we're choosing 3 boys and 3 girls. Okay, this is 2 different situations that need to be brought together. There are going to be a total of 6 students chosen, 3 of them from the group of boys, 3 of them from the group of girls. So we will need to do this in 2 separate problems again. So 3 boys, so there's 8 boys, and we need to choose 3 of them. And, remember with and, we're going to multiply and 3 girls. There's 11 girls, and we're going to select 3 of them. Now we already computed both of these from above, so 56 from the first problem, and we need to multiply that by 165. And when we do that, we get 9,240 different ways that 3 girls and 3 boys can be chosen for a game. The last one, in how many ways can 3 boys or 3 girls be chosen for a game? Okay, so we're going to use the same 2 options again. So 3 boys out of 8, so 8C3, and 11 girls, and we're going to choose 3 of them. But now or means we're going to add, because there's either this many options or there's this many options, and then we will get our solution here. So we need to add 56 plus 165, and we get a total of 221.